SQL injection is a cybersecurity vulnerability that allows attackers to interfere with the queries that an application makes to its database. It usually involves the insertion or injection of malicious SQL code into a database query, which can give attackers unauthorized access to the database, allowing them to view, modify, delete, or add data. This can lead to a wide range of issues, including data breaches, loss of data integrity, and unauthorized activities. SQL injection attacks exploit vulnerabilities in the application's software and can affect any website or application that uses an SQL database. Understanding how SQL injection works and its potential impacts is crucial for developers, cybersecurity professionals, and anyone involved in maintaining secure web applications and databases. Structured Query Language, SQL, is the standard programming language used for managing and manipulating databases. It provides a systematic, powerful means of accessing, modifying, and querying data stored within a database management system. SQL enables web applications to interact with databases to fulfill functions like retrieving specific information, updating records, and executing transactions. Virtually all relational database systems, such as MySQL, PostgreSQL, and SQL Server, utilize SQL as their foundation. By structuring data in tables comprised of rows and columns, SQL databases allow for efficient organization and retrieval of data. This brief overview sets the stage for understanding how SQL injection exploits the communication between web applications and databases, highlighting the importance of secure SQL practices. SQL injection attacks manipulate the normal operation of database-driven applications by inserting or injecting malicious SQL statements into a query that an application is making to its database. This is often achieved through user input fields, such as login forms, search boxes, or URL query parameters. Attackers craft input that is not properly sanitized by the application, causing the back-end SQL server to execute unintended commands. These commands can lead to unauthorized access or modifications to the database, allowing attackers to read sensitive data, modify database data, delete records, or even issue commands to the operating system in some cases. The essence of an SQL injection attack lies in deceiving the database into executing malicious SQL statements by exploiting vulnerabilities in the way an application constructs its SQL queries. This can often be prevented by strict input validation, parameterized queries, and other secure coding practices. The impact of SQL injection on websites and databases is both profound and damaging. These attacks can compromise the security and integrity of data, leading to unauthorized access to sensitive information. This could include personal details of users, financial records, and proprietary business data, putting individuals and organizations at significant risk. Furthermore, SQL injection can cause a loss of data integrity, where the accuracy and reliability of the data within the database are compromised. This scenario may result in incorrect data being presented or processed, which can have serious repercussions for decision-making processes. Additionally, these attacks can lead to a complete loss of availability, where the affected databases and potentially the services or applications they support become inaccessible to legitimate users. This could manifest as disruptions in online services, tarnishing the reputation of businesses and leading to a loss of customer trust and potential revenue. The overarching effect of SQL injection on websites and databases underscores the critical need for robust security measures to protect against such vulnerabilities. The history of SQL injection attacks dates back to the late 1990s, when the rapid expansion of the Internet led to wider use of database-driven websites and applications, exposing vulnerabilities not widely recognized before. One of the first major public discussions about SQL injection was in a 1998 issue of Frack magazine, which detailed how attackers could exploit SQL queries by inserting malicious inputs. Since then, SQL injection has evolved to become one of the most prevalent methods for attacking web applications. Over the years, numerous high-profile attacks have demonstrated the severe implications of such vulnerabilities, prompting the development of more secure coding practices and heightened awareness around database security. Despite these advances, SQL injection remains a critical threat, reflecting the ongoing challenge of safeguarding web technologies against evolving cybersecurity risks.